Let's start 7.4, adding and subtracting rational expressions. And in this section, we're doing a lot of stuff similar to adding and subtracting regular fractions, except we have a denominator that has variables. It could have binomials to it, a trinomial. And bottom line is we still have to get common denominators before we can add and subtract. That's definitely something different when it comes to multiplying and dividing fractions. Because with those types of problems, you didn't have to have common denominators, but you do here. So let's take a look and see what the core concept shows us. And the first part right here is pretty much saying, look, you have to have common denominators, with right here being C, and then you're able to add and subtract the numerators together. Okay, and the same thing happens right here with the denominators. Common denominators of C, or whatever it might be, binomial, trinomial, and then you can go ahead and subtract. Don't forget, when you're subtracting, you got to make sure you change the signs of the numerator, or at least of what's being subtracted by. If not, you're going to end up with a lot of trouble. What I do see a lot of times happen in this section is that students begin to start cross canceling straight from the beginning, and you can't cross cancel like how you did in section 7.3. We'll kind of take a look at show you what to do and not to do right here. So what do we do in order to get common denominators? If you take a look right here in this part, look, if I look at the two denominators here, we have C and D. Well, one of the things that I always look for is, well, what does the other denominator have that, like the one on the left doesn't, the A over C? Well, it's a D. So what I will do right here simply is multiply top and bottom by D. And then I take a look at the second fraction, B over D. And then I'm saying, well, what does the first fraction have that this one does not? And that is C. So then I'll end up multiplying top and bottom by C right here. And so once you have, your common denominators and you do your little multiplication, then you can go ahead and add things together or subtract things and then get your final answer. If you look closely, hey, I see a C and a D and all that kind of stuff, top and bottom. But remember, we just added things together. And sometimes what I see students do is they start canceling out the D's right here. And you can't do that. Okay? The C times D is together, the A and the D is together. However, it's a combination, it's a set. So it's being added together in the numerator, so you can't just begin to start canceling things like how you thought you could in the in what is it, 7.3. So don't fall into that trap. Okay, so what I just did right there, you cannot do. Okay, next up, simplifying complex fractions. Okay, there's two methods here that's being shown. Method 1 says, if necessary, simplify the numerator and denominator by writing each as a single fraction, then divide by multiplying the numerator by the reciprocal of the denominator. Method 2, multiply the numerator and the denominator by the LCD of every fraction in the numerator and denominator, then simplify. So kind of what I showed you in the previous core concept right there, you want to multiply the numerator and denominator by what the LCD is, okay? Or sometimes, what does the other side have that the other, one fraction have that the other doesn't? And then from there, hey, you can go ahead and simplify things. The last thing right here that I added right to our notes is finding the LCM. How do I find the lowest common multiple? That is the LCM. And it's by factoring each polynomial. Okay, step 1, and then write the numerical factors as product of primes. 2, the LCM is the product of the highest power of each factor that appears in each in either polynomial. So let me give you an example right here. Let's say the question was, let's find the LCM of 4x squared minus 16 and 6x squared minus 24x plus 24. So step one is we want to factor out each polynomial as much as we can. So 4x squared minus 16, hey, I could factor out a 4, and I'm left with x squared minus 4. And then right there, x squared minus 4, we have a difference of 2 squares, one of our special factors that we've talked about many a time. So this could factor into x plus 2 and x minus 2. Let's go ahead and do the same thing with the second trinomial. Looks like I could factor out a 6. So let's go ahead and do that. And I got x squared minus 4x plus 4. And let's take a look and see right here. This x squared minus 4x plus 4, that does factor into, we got ourselves x minus 2 quantity squared. Factors of 4 that equal negative 4, negative 2 and negative 2. So that's where we got x minus 2 right there. Now, one of the key things here is we got to make sure we write the numerical factors as product of primes. Well, if I take a look right here, like in what's in blue, hey, that 4, I could rewrite it even further. And what could I change that to? Product of primes. Hey, that's 2 squared right there. Okay. There's nothing more else that I could really do right here on that. So we'll go ahead and leave that as is. And then with that 6, I can go ahead and product of primes would be 2 and 3. Okay. So now I take a look at the 2. We had our 2 polynomials, and I'm taking a look at what are the highest of each product. And I see right here I've got a 2 to the second power. That's the highest power, right? Because step 2 says this LCM is the product of the highest power of each factor that appears in either polynomial. We also have an x plus 2 and x minus 2. We have ourselves this 3, and then actually the highest power between x minus 2 is not the one on the left side, but it's actually this one right here on the right, this x minus 2 quantity squared. So I'll go ahead and highlight the highest powers right there in purple. So now, if I'm saying, well, what is the LCM? It's going to be a combination of all of this together. And so I'll go ahead and write, we got 2x, or 2 to the second power. And then we have ourselves times 3. And then we have ourselves times x plus 2. And then x minus 2 quantity squared. And all of this right here will represent our LCM. Okay, so you want to try to break it down as much as possible using the product of primes right here. All right, we'll eventually come back to some more of this, and let's take a look now at finding the sum and difference. So number 1, okay, should be pretty straightforward, pretty easy. I'm looking at my denominators, and they are both the same. Right here we got x minus 1. So we just go ahead and simply subtract the numerators, 1 minus 5, and you're left with negative 4 over x minus 1. All right, and there you go, just like that. Let's go to number 2. I see right here, okay, once again, denominators are the same. So simply put, let's go ahead and add the numerators together. That's 4x plus 4. That gets me 5x over 3x minus 5. All right, there you go. Do not add the denominators together. I see some people, they try to give me 6x and then minus 10. I've seen 6x squared minus 10 where they start combining multiplying and dividing and all sorts of things all together at once. And that you cannot do. All right. Next up, let's take a look at number 3. Okay. Well, let's see what we could do here. We got common denominators, so let's go ahead and add the numerator, and I got 6x plus 24 all over x plus 4. Okay, if you could factor out more, then you better factor out as much as you can. Because it looks like right here, I could still factor things out. I could factor out a 6, and I have x plus 4 in my numerator, all over x plus 4. Well, guess what? That x plus 4 right there can cancel out. And so in the end, what I'm left with now happens to be equal to 6. And that would be my answer. Okay? But think about what we just learned right here in 7.3. Look at your answer. I have a denominator there, but that's no longer there anymore. So that means that I have a restriction. And then so part of your answer, we have to put that x cannot equal -4. Okay, so both of these combined right here will end up getting you your answer. All right? We can't have a restriction. Or if we have one, we got to write it down. Because once again, I don't know that x cannot equal -4 in the problem unless I plug things in. Okay? So you can go ahead and add your restriction right there. Let's go ahead and move along. Let's take a look at number 5. It says find the least common multiples of the expressions. Okay, so let's kind of take a look at what we did earlier. I look at 9 times x to the third. And can I simplify 9 any further with product of primes or with prime numbers? And I can. It's 3 squared. Can't do much with x to the third. That's the highest power. We leave that there. How about the next binomial, or the next one, which is a binomial? Well, it looks like I could factor some stuff out. How about I factor out a 3x? Okay, and then from there, I go ahead and end up with x minus 7. So I'm looking now. What are like the highest powers of each term? And then we'll put it all together. Now, if I examine this closely, this 3x or 3 squared times x to the third, that right there is 9x squared, right? We already know that. But if I compare 9x squared and then, or the 3 with right here, what we see, the highest things that I have is this 3 to the second power. I've got this x to the third, because that's higher than 3 and times x, right? So the highest powers, and then this x minus 7. So what's the least common multiples of the expression? We got 3 squared times x to the third times x minus 7, and that right there is your LCM. All right, so we have that now. On all of these 6 and 7, you've got to factor things out, okay, in order to get your answer. So make sure you factor things as much as possible, and then try to look and see, well, what does one side have that the other doesn't? And if there's something they both have in common, well, you only write it down once. Let's make things a little more complex. Let's go down to number 8. So on number 8 right here, now we finally see problems where we do not have common denominators. So the easiest thing to do as well, I look at 2x and 5x, and I'm like, well, what can I multiply both sides by to get my LCM? Well, it looks like you could always multiply the two denominators together, and you'll get yourself 10x squared. And so you would take like this 11 over 5x and multiply it by 2x, and then you take the 3x over 2x and multiply that by 11 over 5x. You can do that. But then you start having, like, we really don't need to because they both share an x. The problem is that 2 and the 5. Well, the LCM right here is going to be 10. So what we need to do is go ahead, I'll take this 11 over 5x, and let's multiply top and bottom by 2. I take the 3 over 2x, and I'll multiply top and bottom by 5, the denominator of the other side. Now, once again, the easiest way is to say, hey, how about I multiply the left by 5x and the right by 2x? You can do that. You'll just have to start simplifying a little bit more at the end. Okay, so remember, after we do this, we go ahead and multiply. 5 times 3 is 15. My denominator is 10x. 11 times 2, 22 over 10x. So now that we have common denominators, we can go ahead and add things together. And then this simplifies down to 10x. And then we got 15 plus 22, which is 27. If you can reduce or simplify things, then you do so. But if not, we can go ahead and leave it as is. And 27 over 10x, or sorry, this should be 37 over 10x is your answer. Okay? What would happen if you multiply top and bottom by 5x and 2x? You'll get 37x over 10x squared. And then you'd be able to simplify the x's. Okay? So therefore, either way, you will get the answer, but you might have to do more steps in the work. Let's take a look next up at number 9. So right here, I'm taking a look at the 15 over x minus 2. The easiest way to look at it is what does the other denominator have that the one on the left does not, and it's x plus 8. So I'll multiply top and bottom with x plus 8. With the numerator, make sure you multiply, but you got to distribute. So we have 5x, and then plus 8 times 15, and that looks like it's 120. All over. And now right here, we'll just go ahead and leave this as my binomials of x minus 2 and x plus 8. No need to FOIL that, because there's a good chance we're going to be able to cancel things out at the end. So please do not multiply those things or multiply it out. Let's take a look at our right fraction, the 3 over 8, or x plus 8. Multiply top and bottom with x minus 2. And so right there, I'm going to distribute that 3. I've got 3x minus 6 over x minus 2 and x plus 8. So I've got common denominators. So now let's go ahead and simplify things by adding things together. My denominator will be x minus 2 times x plus 8. Okay, that will stay the same. The numerator, we combine like terms. So we got 15x plus 3x. You got 18x right there. And I got 120 plus negative 6. That's going to be positive 114. All right. We always want to try to simplify as much as we can. So right here, let's go ahead and simplify. Looks like I could take out a 6. Okay. So if we can factor things out, that's what they're going to want on your homework. We factor out the 6. I've got 3x plus 19 over, we've got x minus 2, x plus 8. All right, there we go. As if things couldn't get any more hard or more difficult, we take a look next at number 10. Okay, so we want to factor things out as much as we can to begin with. I look at the denominator on the right, and I've got 2x squared minus 5x plus 3. Okay, and we got to be able to factor that out. In case you forgot, remember, how do I factor out a trinomial like this? I always list what are some factors of 2. I got 2 and 1. Factors of negative 3. I could put 1 and negative 3. And then we cross multiply to check to see if those are our correct factors. So I'll multiply like this because this represents the outer and inner of a binomial. So I got 2 times -3, that gets me -6. I got 1 times 1, that equals 1. And then I get the two numbers 1 and -6. When I add those together, that gets me -5, which happens to be the middle term. See, we get -5 right here, and if I look at the term in the middle, that's -5. So that means I did this correctly. Okay, if I have all of that done, then I did this correctly. Okay, so my two binomials, all right, what are they? One of them is going to be 2x plus 1. The other binomial is x minus 3. All right. So now, I'm going to go ahead and do a little bit reorganizing. I want to erase the work that I did to get those two binomials. I want to go ahead and let me go ahead and move that right there, because what essentially is going to happen right here is that, hey, I'm going to take that 2x plus 1 and x minus 3, and I'm going to substitute that, okay, substitute the 2x squared minus 5x minus 3. And so when I take a look at the denominators right here, okay, so let's just think, I put it over right there. Okay, so I have it right there. And it's getting destroyed. All right, there we go. Go ahead and go back over here. I look at my denominators now. I look at the fraction on the left. I've got 2x plus 1, but the other side does not, right? So what do I do then? Remember, I multiply the denominator of the left with what the right side has that this side doesn't, which happens to be x minus 3. And so I'll multiply top and bottom by x minus 3. All right. So now let's go ahead and rewrite things out. I want to distribute the numerator right there, and I got 3x squared minus 9x over, I got 2x plus 1, x minus 3, plus 10 over 2x plus 1, x minus 3. So now we have common denominators, and I can now go ahead and add the numerators together. So I've got 3x squared minus 9x plus 10. We want to write this in descending order, just like always. And that's going to be over 2x plus 1 times x minus 3. And there you go. I can't do anything else with the numerator, so we'll just go ahead and leave it as is. All right, let's take things one step further. Take a look at number 11 real quick. So we have 3 fractions. But the thing right here is I've got this x squared minus 6x minus 7. So right there, I'm going to have to factor things out. Okay, factors of -7 that add up to -6. That right there is x minus 7, x plus 1. -7 times 1 is -7. -7 plus 1 equals -6. All right, so there you go. So I'm looking right here. I've got x minus 7 in the first fraction. Okay. And I look over there on the other 2 fractions, and I've got an x plus 1. So I'm going to have to multiply this top and bottom by x plus 1. Okay, because then that'll match the last fraction, right? With the middle fraction right here, I only see x plus 1. I'm going to have to multiply this top and bottom with x minus 7. And you might need a lot of space in your notes, guys. Don't try to fit everything into one little space or else you're going to get yourself confused. And then with the last fraction, well, now they all have common denominators. They all have those two same binomials, so I don't need to do anything with that. So let's start combining things together. I got x times x plus 1. That turns into x squared plus x. And we've got our denominator x plus 6, x minus 7. Or sorry, x plus 1 times x minus 7. In the second fraction right here, there's a minus sign in between. So that really tells me that this is negative 2. Okay? If you don't do that, you're going to have the signs all wrong, all messed up, and you're going to get the wrong answer, unfortunately. So you got to make sure we distribute the negative 2. And so I'm going to have negative 2x plus 7, or sorry, plus 14, because remember it's negative 2, and then you go multiply that by x, and then we have negative 2, you're going to multiply that by negative 7, so plus 14. All over right here, we've got x plus 1, x minus 7. And then finally, the last one, let's just go ahead and make sure we'll change the signs. And I've got right here, we have plus, and then we got negative 8x over x plus 1, and then x minus 7. And then I snuck in right there a little plus sign in between the first two binomials or fractions, because when I change the signs, remember, subtracting is adding the opposite. So I put a plus sign there. And now we can go ahead and add things up together, but we already have the signs changed and taken care of. All right, so now x squared, I don't see that anywhere else. So let's go ahead and put this as x squared. We have ourselves minus x, or sorry, it looks like we got x minus x plus negative 8x is going to be minus 9x. And then we have ourselves plus 14 over x plus 1, x minus 7. Remember, maybe, just maybe, you could factor things even more. And we can right here. And I could factor this x squared minus 9x plus 14 to become x plus x minus 7, x minus 2. Negative 7 times negative 2, positive 14. Negative 7 plus negative 2 is negative 9. So in case you think things couldn't get any harder, hey look, x minus 7's cancel out, and now I have x minus 2 over x plus 1. And there you go. We have now finished this problem. All right, so you can see right there where the signs are, or all the different factors, and then we could actually look. You can see there's no plus sign in between in our answer, and so that, hey, I could start cross-canceling things out or reducing things down. All right, and there you go with number 11. And so I gave you many different examples right here of what to do when you're adding and subtracting these fractions. Pay close attention, making sure, I think you need to go back and kind of refresh on factoring. If you're having a hard time, you're saying, I don't know what to do here on some of the steps, and make sure you know how to find the LCM. All right, and there you go. go ahead and get to that homework.